This is my video on 6.3 numerical model. What is the numerical model? The numerical model is split up into three motions: linear, angular, and projectile. Linear motion is split up into two subcategories: rectilinear and curvilinear. Rectilinear motion is the movement in a straight line, for example in a 100-meter sprint. And curvilinear motion is the movement in a curved line, for example 200-meter sprint on a bend. Linear motion has two factors: distance and displacement. Distance is the sum of all the movements regardless of the direction. For example, the distance of a sprinter runs is taken as a value. But on the other hand, displacement is the straight line distance from point A to point B in a particular direction. For example, the direct route, also known as the crow flies, as a value. Also the directional value, this is taken in degrees. Linear speed and velocity. The definition of speed is how fast a body moves. This is measured in meters per second. The equation for speed is distance divided by the time taken, which equals the speed. Velocity is how fast a body can travel in a direction. This is also measured in meters per second, but the equation is different. Velocity equals displacement divided by time. Acceleration is the rate of which an object can change their speed. Acceleration equals change in speed divided by time taken. Newton has three laws of motion: inertia, acceleration, action and reaction. Inertia is the reluctance to change. For example, in basketball. So in this example, the basketball is reluctant to change, and we are having to exert a force to be able to change the way it moves. Acceleration is determined by forces and the direction. It is directly proportional to the magnitude of the net force. Action and reaction is when there is always equal force opposing against something. So for example, in a 100-meter sprint, the blocks would be the reaction to the action of you pushing against them, and they are opposing a force against you. The center of mass and stability. The center of mass is where the body is equally balanced in all directions. There are two things that influence this. Weight influences the way the center of mass moves and acts on the body. Stability is related to moving the body in such a way it moves from its balanced position. For example, in basketball, when you are balanced from the starting position of the jump, and then when you go to jump in the air, your body becomes unbalanced as the center of mass has moved, causing you instability. Factors increasing center of mass are lowering your position, the line of gravity in the base support, and there's more points of contacts. So, as I said, instability is needed to be able to create certain movements in sports to complete the movement. So, for example, a gymnast would have to cause instability to be able to make the correct movement that she needs. So this is the second part of the numerical model, and this is the how it is used. So how the numerical model is used. It can be used in any professional sport, so NBA, and it could be used for tennis players. It is used to analyse their strengths or weaknesses as a player. So, for example, in basketball, if they're practicing their layup shots, they would look at the weaknesses and the strengths in this, and this would lead into their technique into the layup. And it can also look to see if there's anywhere in the game that they could be causing injury to themselves. And for example, if they are going for a layup shot and they are going to jump, they would look at how they're going to land. Would they be landing on their toes or on their heels, or would they land flat-footed? And this could cause any sort of knee injury. And this is the method of how they would prepare the participants. So there are 3 protocols to preparing the participant. The first protocol was making sure that they had the right equipment on them. So we had to put on sensors which would pick up infrared light to analyze them, and also we used them to measure the angle of what their joints are whilst they're jumping. And so this is linked into the second part of the protocol. This is where we had to do the videoing. So a group of people responsible for videoing the participant to be able to analyze their technique in closer detail. They had to make sure that they had the camera at the right angle and they had the whole of them in the jump from start to finish. The final protocol was to make sure they were in the right position when they came to jump and that their legs were in the correct angle. When doing this, we had to calibrate the force plate to the correct weight of the participant so it could measure the correct data in the correct way. So with the camera, we had to set it up in different ways, and there are other ways we could have done it. So there are 2D and 3D ways of capturing video. The 2D way is very limited on the way it can video, but it is very useful for measuring angles and finding the angle in the joints of when the performer was jumping. But the limitations are that we could only see one joint, and we couldn't see how they were working all together. So this is what the 3D video is better for, as you can use this to look at how technique is being used in the jump and how it is affecting the joints. So we will be comparing 2 different performers in 6.4 video.